Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over the section of inverses, which is section 2.7. Um, we're going to talk about what exactly an inverse is, okay? So an inverse essentially is going to be a flip of you can almost think of it as an opposite of your original function, okay? I'm going to kind of jump around a little bit for the following. So the idea is when you have a domain and range, what's going to happen is that whatever your domain for your original function is will become your range, and then whatever your range of your original function is, it's going to become your domain. Okay? So what does that mean? Okay, so visually it means the following. Okay, so and again, we have another topic in which there'll be kind of a visual component and a mathematical component. I would say of the two, the mathematical component is a lot more important, but the visual does really help you kind of understand what's happening. Okay, so the idea is your inverse is flipping your domain and ranges around, or in other words, our x and y's around. Okay, so we have a bunch of graphs. Let me kind of make this a little bit larger for the following here. Okay, so this right here is the following. We have a graph and we have these points, right? We have -2, 2, -1, 0, 0, 1, 1, 2. And so the idea is for an inverse, right, your x becomes y's and your y's becomes x. Why is that? Because, right, because my domain and my range flip. Okay, so I'm going to look at these points that we have, right, and I have -2, -2, -1, 0, 0, 1, and 1, 2. So if I graph my inverse, what's going to happen? What's going to happen right here is that my x's and y's will flip. So -2, -2 will stay the same. -1, 0 will flip. It will now become 0, -1. 0, 1 will flip and become 1, 0. And then 1, 2 will flip and it will become 2, 1. Okay? So I have -2, -2, 0, sorry, -1, 0, 1, 0, and 2, 1. And if I connect these points here, it looks like this. Okay, like the following. Okay. Now, let's look at the other example right here. I have the following. So I also have -2, -2. I have 0, -1. I have 1, 0. And I have 2 and 1/2. I'll just do 0.5. Okay. So I'll do the same thing and I flip them. So -2, -2 flips. 0, -1 flips around. So now it becomes -1, 0. 1, 0 will flip and it'll now become 0, 1. And then the last one will flip and it'll be 0.5 and 2. And so it looks like this, okay? Now, here's a thing to take a note for the following. What do you notice here? If you notice with both of these problems, the red, right, the picture I draw in red is essentially a mirror image of the blue, right? They're kind of like essentially the same. They have the very same shape. It's just they're kind of like opposite of each other. And they actually reflect over y equals x. So the idea is, right, this is your original. And this is your inverse. And your picture essentially flips over y equals x, and they should be kind of mirror images of each other. If they're not, then you did not graph your inverse correctly. And this is what will happen all the time when you have an inverse, because your x will become y's and your y's become x, or sometimes we say your domain becomes your range and your range becomes your domain. Okay? Now, there is kind of a small thing you do have to be a little bit careful about when we talk about inverses. Inverses must pass what's called the 1-to-1, okay? So it'll be 1-to-1, or it'll say 1-1, okay? So the 1-to-1 test is if every horizontal line intersects the graph of a function, then at most in one point, then it'll be 1-to-1. So what does that mean? Okay, horizontal line test is just like a vertical line test, only you draw a horizontal line, right? So a vertical line test, if you remember, is if it only goes through at most one point, it's a function. Horizontal line test is if it goes at most one point for a horizontal line, then it's 1-to-1. Okay, 1-to-1 just means that your inverse for your function becomes a function. Okay, so okay, and then if you read right here, this is, I'm not going to read this out to you, but this is also kind of another clarification for them. Okay, so if I look at some of these graphs here, right, 19, right, if I draw a bunch of horizontal lines, right, I'm only going through one point at most, so this one's 1-to-1. Same thing with this picture here. This is also 1-to-1. Sorry, I should probably literally spell out 1-to-1. Yeah. Sometimes, yeah. And then the other thing too is they do a 1-1. That's essentially saying 1-to-1. So just want to emphasize that so you don't get too confused. Okay. Now notice here, this third picture is not 1-to-1. Why? Because if you notice, it crosses 2 points. Okay? And remember, it doesn't matter if it happens just once or multiple times. It doesn't matter if it crosses 2 or 20 points. It's automatically not 1-to-1. Okay? Now let me erase that red portion of this graph, of this absolute value. And so the idea is, remember, okay, this is going to be a little bit hard to see here, but let me kind of show this to you here, right? So y equals x, right, if you remember, looks like this. If I reflect my picture, okay, and I draw my picture and I replace my x's, y's, right, and I swap them, my absolute value is going to look like this, okay? So the reason why it's not 1-to-1 is, notice if I graph my inverse, which is in purple as you can see, notice that it will not cross a vertical line test. My inverse is no way a function. So again, that's what 1-to-1 means. 1-to-1 means that if you flip it, right, or if you turn your inverse has to be a function as well. So in that case, my absolute value is not 1-to-1 because the inverse clearly is not going to be a function. Okay. Okay. Let's talk about the following here, okay? We are being asked to find what's called an inverse function, okay? Now, we're going to do a lot of practice of these. Some of these can get pretty easy and some of them can get really difficult, okay? There's a lot of variance in these types of problems in terms of the level of difficulty, but the concept should be pretty straightforward, okay? So remember, the concept is, remember, all your x becomes y's, all your y's becomes x, right? So we're going to start off with number 1. It's an easy one. So I have, essentially, remember, f of x, remember, same thing as y, so I have y is equal to 3x. So if I want to find my inverse, what happens is, right, my letters flip, right? So all my x becomes y's, all my y becomes x. So I have x is equal to 3y, And then what I'm going to do is I'm going to solve for y. Thankfully for us, this one's a lot easier to solve than ones we're going to do later on. So all I do is divide by 3. So I have y is equal to 1/3 x, okay? And when you're doing MyMathLab, also if you look at a book, they will write it like this. You see this little -1 on top? That's called inverse. So we say our inverse is going to be 1/3 x, and that's my final answer. Okay. Okay. Let's look at our example. Let's look at number 2. So we are going to do the following. So let's start with this one here. And it's going to be the same situation at hand, right? So I have y equals x cubed minus 1. And then, again, my x's and my y's just kind of swap if I want to find inverse. Okay? So you're going to add 1. Okay? So remember what we're going to be doing now is we're going to be solving for y. Okay? So, and then you'll take the cube root on both sides. Right? Because if I take the cube root on both sides, remember what happens is the cube root cancels out with the power of 3. So I'm left with y is equal to cube root of x plus 1. Other known as f inverse of x is cube root of x plus 1. Okay? And so I think kind of the issue at hand is not the concept, right? I think so. Every single problem that you're going to start off, it's going to start off with x and y swapping. The thing that kind of gets to a lot of people is how to solve for y, because obviously the situation will change, right? The one we just did was pretty easy, you just divide by 3, but the one we did here, right, we did have to do a couple additional steps. Okay? Now let's talk about one thing. So how do you know if you did something right? Or how do you know if you have the right inverse? You can check by doing something called composites. And so back in the last video, I talked about composites, and there was what's called a special case, and it was an inverse. So the rule is this. If I take a composite of my original by my inverse, and it becomes x, and then if I take the inverse composite of my original and it becomes x, then this is an inverse, okay? So if I do composite both ways and they end up being x, I actually have the right inverse, okay? So let's just do a recap of what happens here. We should remember how to do composites. So I'm going to do the following here. So my inverse is, right, we know f inverse of x is cube root of x plus 1. And then I'm going to plug this right into my f of x. So it's going to look like this. F of cube root of x plus 1 is going to be equal to cube root of x plus 1. Sorry, let me make this a little bit cleaner. Which will then become x plus 1 minus 1, which will be equal to x. Okay. Oops, sorry. And so that works out right there. And then I'm going to do the following here. And I have this one becomes f of x is equal to x cubed plus 1. And we're going to do the same thing. We're going to replace x cubed plus 1. We're going to plug it into our inverse. And this is going to be the following. So remember, I replace x with x cubed plus 1. So instead of cube root of x plus 1, or sorry, this should be minus 1, my bad. I can plug it into my inverse, and so instead of saying cube root of x plus 1, I'm going to do cube root of x cubed minus 1 plus 1, okay? Cube root of x cubed, and it equals to x as well. So it works both ways, okay? For the following, okay? And then let me just show you how to check with, so let me show you how to check with the first one that we did as well. Okay, so we can do f inverse, so I can do f of f inverse of x and f inverse of f of x. Okay, so this is the following. You are going to do this. So let's see, my inverse is 1/3 x, so I'm going to do, this will become f of 1/3, which will become 3 times 1/3 x equals x. That works. Now let's look at the next one. And then I'm going to do the following here. So my f of x is becoming 3x. And then I plug into my inverse, so it's 1/3 times 3x, which will become x. That works out as well. Okay. Now, let's talk about this here. Okay, so in your concept checks, in your homework, right, sometimes they'll just say find your inverse. So if you find your inverse, you're good. Okay. You don't have to do the check by composites, but sometimes they may ask you to do what's called check by composite, or like show that these two things are inverses of each other, so you can do composites. Okay. Now, if they don't say say a specific way to check, you can also check using your graphing calculator. Okay. So what do I mean by that? So the idea is, let me go back to my Windows, my regular Windows. Okay. So if I graph my original function, which is 3x, and if I graph my inverse, which is 1/3 x, we should see what happens when I graph them. So I graph 3x and I graph 1/3 x. Notice I get the following right here. Okay. These two graphs, right? If I graph y equals x, notice here. So let me just do the following. Let me graph y equals x. So if you notice, these two graphs reflect over y equals x, right? They're mirror images of each other. Okay, so always remember that. If you graph them, you can see they kind of like reflect off each other. That's another way to show that they're also inverses, okay? But if they want you to prove using composite, you must use composites. You can't just use your graph. But this is a good visualization to check. Okay, same thing. So let's see if I do cube root of x plus 1. Let me show you how to do cube roots, okay? You could do this. You can do math, and you go to option 4. You can do cube root of x plus 1 like this. Okay. Now, or you can do it like this, x plus 1. And remember, cube root is the same thing as raising something to 1/3. So I can do exponent and then parentheses 1/3. And then I'll do my x cube minus 1. Okay, so let's look at what happens here. Oh, whoops. Sorry about that. I'm going to replace the y2 with x, because that's where it's reflecting across. Okay. As you can see, they're all mirror images of each other right here. Okay. Okay. Okay, so let's continue right here. So I'm going to do a couple more examples. And some of these can get a little tricky, but I think it's important to do these right here. So same thing, number 3. Okay. Number 3, we're going to do the following. I am going to, I have y is equal to 2x minus 3 over x plus 4. And I'm going to change my x and y's around. So x is equal to 2y minus 3 over y plus 4. Okay, and I'm going to solve for y. Okay, now, trick is, right, if I have fractions, I want to get rid of the bottom part. So what I'm going to do is I'm going to multiply both sides by y plus 4, like this. So this cancels. Or wait, whoops, sorry. That one does not cancel, but the one on the right does. So you're left with this, right? xy plus 4 is equal to 2y minus 3. So you have xy plus 4x equals 2y minus 3. And then you'll subtract 2y. So now let's talk about this here, okay? So remember, when you're solving for y, or if you're solving for a letter, right? In order to solve for that letter, you must get all of those letters on one side and everything that doesn't have a letter on the other side. So since I want to get all my y's together, what I'm going to do is I'm going to move this 2y over, which becomes negative. And then I'm going to move the 4x over, and that will make it negative like this. So as you can see, right, all my y's are on one side and everything that's not a y is on the other. Okay. Now, how do I solve for y? Remember kind of back in your early algebra days, right? If they both have the same thing, you can factor it out. So they both have a y. You can pull a y out. And then divide both sides by x minus 2. And so I have y is equal to negative 4x minus 3 over x minus 2. Okay. Now, let me also talk about this as well. So notice when we were subtracting, right? You could, right, if you want, move the xy over, and it'll be 2y minus xy. That's fine too. So the idea is if you go that way, your answer will be slightly different. I believe it'll be like, yeah, it'll end up being 4x plus 3 over 2 minus x, and technically they're the same thing. So don't sweat it if like you have kind of slightly different signs from here. There are some small variants, okay? But that's okay. As long as you do everything correct, you should be fine right there. Okay? Okay. Let's look at one more here. Okay? Number 7. So I have y is equal to 2x over 3x minus 1. I'm going to flip my letters around once again. And I'm going to solve for y. So again, if I want to get rid of the bottom part, I'm going to multiply both sides by that. I'm going to subtract the 2y over. I'm going to bring my 2y over and turns negative, okay? Because, right, I want all my y's on one side. Now this negative x, right, doesn't have a y, so I'm going to move it over. Okay? So, which is what I want, okay? So, since they both share a y, I'm going to pull the y out. And then divide both sides by 3x minus 2. Okay, so my inverse, sorry, let me scroll down, is x over 3x minus 2. That's my final answer here. Okay. And then if you want, you can do composite both ways. This one's a little tricky if you want to do composite both ways to check. Okay. Try to do this, but then if you have questions, send me an email. Okay. These do take a lot of practice, and you can see some of them can be pretty easy, and some of them have a lot more steps. Okay. So make sure you know how to do it mathematically and visually. But yeah, other than that, I'll see you guys later.